Hello, we are Mariana Mendez, Frida Torres, Rafael Papaki, Abigail Gomez, and Fernando Villar, third semester students of architecture and civil engineering. In this video, we are going to explain the construction process of our project called Meridiano Pavilion, developed for our course Materials and Construction Procedures. The objective of Meridiano is to show how architecture and civil engineering can work together in a single system. We didn't just want a nice model, but a model where the loads, the joints, and the construction sequence could be understood. Our pavilion is located next to Mo Williams building at UTLAB on a 20 by 20 site with a 0.80 meters slope that was assigned to us. The concept of Meridiano comes from the idea of a clock. Just as a clock needs synchronized hands and gears, our pavilion depends on the collaboration between architecture and civil engineering. As a guiding idea, we decided to keep the image of the clock, which appears in our roof, through precision and symmetry. The user's path also follows the same logic. It develops along a circular layout that evokes the movement of the clock hands and leads them to the central point. Likewise, the lattice of the roof is intentionally divided into 4 quadrants. This element creates a play of light throughout the day, revealing the position of the sun at different moments and establishing a direct connection with how a clock works. Here you can see the floor plan and some sections. From the grid, we define the central space, the perimeter circulations, the stairs, and the furniture. This stage was key to coordinating dimensions between the drawings and the model, and to making the main joints clear before moving into the physical model. To build the scale model, we used simple materials, but each one represents a real system. Heavy cardstock for walls, ceiling, and furniture, simulating light panels such as drywall and plywood. 3mm MDF for the trusses, representing steel trusses or structural frames, footings, and bracing. Balsa wood for the purlins and supports, simulating linear structural wood elements. Thread for the installations, representing cables, and small bulbs to indicate the pavilion light fixtures. These materials allowed us to test proportions, modulation, and joints without losing the idea of how the system would work in a full scale. The formwork was made with elements such as seals, wedges, beams, braces, wheels, stringers, and plywood, including both horizontal and vertical bracing to ensure the stability of the system. When we developed the design of the pavilion in the model, we realized it had some mistakes. Even though we followed the drawings, some dimensions and joints did not match correctly in the physical model, which led us to rethink and adjust the design. Then we moved on to assembling the trusses with 3mm MDF, which simulate light steel trusses. Here it was very important to follow an assembly order and to check the right angles and alignment so that the structure will remain stable. The trusses were used first as a roof over a 30-meter span, then as columns, and finally as footings to simulate foundation, plus bracing to support these columns. At the beginning, the structure was very unstable, so we implemented this type of system to make it functional. Once the main structure was solved, we installed the light wall with heavy cardstock in the area where we have a bar. This wall includes a frame with dense glass, a pink fiberglass installation to represent the real composition of the system. In the model, we included 3 types of installations: CCTV, where we located the cameras and their routes to show how the building is monitored; electrical, where we represented outlets, switches, light fixtures, and the path of the circuits; and plumbing, where we showed the cold and hot water pipes and the points of use. In the next part, you can see the installations made with thread and small bulbs. Even though they are just symbolic, they helped us think about where the wiring will run in a real project and how it will be integrated into the ceiling and the structure without interfering with the circulation. Then we installed the ceiling with heavy cardstock, simulating the light interior roof. This element brings unity to the space, visually orders the structure, and also holds the light fixtures that you can see turned on in the night photos. We used the lattice not only for design reasons, but also to hide the bracing of the trusses. In the area with the change of level, we placed a railing to mark the edge and give safety to the user. We try to keep the same modulation logic of the pavilion so that it will be integrated into the whole and not look like a separate element. Finally, we built the stairs and the furniture with heavy cardstock and balsa wood. With this, we were able to simulate the real use of the pavilion: areas to sit, move around, gathered and looked toward the center. Adjusting the dimensions of the furniture helped us confirm that the path was comfortable and that the space could be used in a continuous way. In conclusion, the Pavilion Meridiano is not just a model, but a technical exercise where we proved that our concept can actually be built as a real system. The model forced us to organize the construction sequence and to coordinate architecture, structure, and installations in a single model. This process leaves us with one key lesson. When all the systems work together, the pavilion functions like a mechanism of a clock, which was exactly the idea of Meridiano.